Hello, everybody. Welcome to Tech Talks. Our DevOps edition today is focused on Splunk infrastructure monitoring and how to get data in. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customers, and we want you to continue in your Splunk journey. We create these best practices and we want you to leverage in your daily role. My name is Amit Sharma and I do product marketing at Splunk. I'm focused on Splunk observability solutions. So today we will do a very quick introduction to Splunk infrastructure monitoring. We'll focus almost exclusively on how to get data in, particularly from AWS and Kubernetes environments. We'll talk about automatic service discovery and out-of-the-box integrations for instant visibility. We'll share some additional resources to help you adopt the product faster. So let's dig in. Splunk infrastructure monitoring is a real-time monitoring solution for the entire cloud stack, including on-premises, hybrid, and multi-cloud monitoring, whether your hosts are running Linux or Windows, whether they are on-premises, for example, in vSphere VMware environment, or on-premises cloud environments such as OpenShift or Cloud Foundry, or they are in public cloud environments such as AWS, Google Cloud, or Microsoft Azure. The solution is purpose-built to support the dynamic and ephemeral nature of containers, Kubernetes, and serverless deployments. We talked about automatic discovery. It can discover not only the infrastructure components such as containers, but also which services are running inside them. For example, Redis, MySQL, ActiveMQ, Cassandra, and many, many more. It provides real-time and accurate alerting based on point-and-click data science algorithms such as automatic outlier detection, historical anomaly, sudden change, etc. It ships with out-of-the-box integrations with technologies that you use every day. So what do you, our customers, get from these capabilities? Customers reduce mean time to detect by over 80%. DevOps teams who use Splunk infrastructure monitoring ship code 8 times faster. And our customers reduce toil, for example, in the manual effort in creating and maintaining alerts by over 90%. Everything starts by getting data into Splunk infrastructure monitoring. So let's get started. So we'll focus on AWS. We will not only talk about these integrations, but we'll see some of the common integrations in action. We give complete flexibility to our customers on how to ingest telemetry data from AWS services. Splunk Open Telemetry Collector is production ready. Splunk supported distribution to collect telemetry data. In addition, customers can also ingest data to Splunk using AWS Open Telemetry distribution. Splunk is a certified backend for AWS distro. AWS services where you cannot deploy Open Telemetry Collector, for example, managed services such as DynamoDB. Customers leverage CloudWatch, including the latest integration with CloudWatch metric streams, which streams performance metrics to Splunk instead of periodic polling, resulting in real-time insights and efficient scalability. For serverless AWS Lambda functions, you can use Lambda extension or our Lambda wrappers. If you're using AWS App Mesh, which is the service mesh distribution, you can transparently ingest microservices performance metrics to get a complete view of the system performance. So looking at the most common methods of getting data into Splunk, customers typically use a combination of these. We'll talk about these connections and we'll see that in action by connecting my Splunk infrastructure monitoring org to AWS. Starting with CloudWatch. As I mentioned, CloudWatch is ideally suited for managed AWS services such as RDS, DynamoDB, and there are many more AWS services managed by AWS. It will have 1 minute, 5 minute, 10 minute polling interval. Typically, customers use 5 to 10 minutes polling interval for get metric data API. CloudWatch metric stream is an alternative to CloudWatch polling, where data is streamed to Splunk using Kinesis data firehose. Data is updated 1 to 2 minutes resolution. AWS costs is up to 70% cheaper than pulling get metric data updates. However, note that you will be getting more frequent updates, because since you are getting updates at 1 to 10 minutes, you'll get more frequent updates than 5 to 10 minutes polling. Metric stream eliminates CloudWatch polling and throttling limits, resulting in efficient and fast data updates. Splunk Open Telemetry Collector is an open, vendor-neutral framework for collecting telemetry data. It can be installed anywhere where you have access to the compute resources or infrastructure. For example, in EC2 or Kubernetes environments. This is our recommended method to get data into Splunk, because it provides high resolution metrics and it is the most cost efficient, as all the metrics that you're getting from your AWS resources are bundled in, are included in your license. So let's see connecting to AWS CloudWatch. So I'm looking at Splunk Observability Cloud, and Splunk Infrastructure Monitoring is a part of a Splunk Observability Cloud. So you might see APM, RAM, or Log Observer. These are other products which is included in this suite, but we're going to focus on Splunk Infrastructure Monitoring. So I'm going to go click on the menu and come to Data Setup Wizard. Here in the integration tile, we have listed a number of integrations that are available with the Splunk Infrastructure Monitoring. I'm going to go and click on Amazon Web Services and add connection. I am going to pick external ID. This is a method, this is a way to provide access to Splunk for your performance metrics on your AWS resources without sharing your AWS secret keys. So I'm going to click on Next, and I'm going to log in to my AWS Management Console. I'm going to create a policy. To creating the policy, I'm going to copy the permissions. Usually you will see the get, list, or describe on your resources. So I have copied this. I'm going to click on JSON, and I'll paste everything that I got, and I will click Next. Review, and I'm going to make it, call it Tech Talk policy, and create policy. I will return back to the setup wizard, and I'm going to create an IAM role for which I need the account ID and the external ID. External ID is a randomly generated string. So let me copy account ID and click on AWS Management Role Console. I will paste my account ID and I will mention that I need external ID. Go back here, copy external ID and paste. Next, permissions. Here I am going to attach my policy, Tech Talk, that we just created. Next, tags, review. I'm going to call it Tech Talk role, and I will create this role. Because I need the Amazon resource name, or ARN, to proceed further in my data setup wizard. Click Next, and I'm going to paste that role. And I'm going to click Next. Now it is accessing and making connection to Amazon Web Services, as well as it will establish the connection, and we see that it has successfully established a connection with AWS. Data from all the regions, or I can specify certain regions. I want to leave it default, getting data from all the regions. Similarly, I can get all the services that I have deployed, or I could just specify services. For example, any of the services I could pick. I am going to leave it and by default and get data from all the services. And that is it. That's our connection to AWS. Once we have connected, within minutes, you will start seeing data flowing into your Splunk infrastructure monitoring. For example, we have whole number of AWS services deployed. I'm going to take a look at EC2, for example. I have a number of hosts deployed in this demo environment, and I get performance characteristics, performance metrics on these hosts. For CloudWatch metric stream, before we progress, we need to get something called realm, where Splunk infrastructure monitoring is deployed, and access token. They are easy to get. So here I'm going to take a look at observability, my organization settings, access token, and I'm going to click on Tech Talk token and copy this. For getting realm, I'll say organization settings, members, and my name or Tech Talk username. This is the realm US1. You will need one more thing, which is real-time data ingestion URL. This is ingest.realm us1.signalfx.com. We are going to copy the permissions for creating the policy. However, we will add these new permissions because now we are getting CloudWatch metric stream data as well. So list, get, put, delete on CloudWatch metric streams. When we will creating the filters on the logs and metrics, we will not select the toggle of CloudWatch metrics, because if we select this, then it will enable the polling. We will also deploy the resources for CloudWatch metric stream. It will create IAM role, S3 bucket, as well as a Kinesis data firehose for us. So for that, Splunk provides cloud formation templates. And let's go and take a look at this list, which is available in our documentation. So it is region specific. You can create per region or multiple region using stack sets. In this example, I'm going to create in each region, in that region that I have deployed. And I'm going to click on this. It will take me to CloudWatch, to Cloud Formation template. And I will provide here the access token that I got previously and real-time ingest required. As one final step, we will also turn on the metric stream collection. For that, we will first need to do a HTTP GET to in this API call. And then we will do a HTTP PUT to enable metric streams sync state. So let's take a look at that as an example. So here I am doing a GET call. One thing to note, in the header, set the value to the access token that you have gotten previously. So now you are looking at, I will do a GET on our API URL, api.us1. Remember, us1 is the realm. And this GET URL will give us the integration object. Once I get the integration object, I'll copy the whole object, and I will do a HTTP PUT by adding these two parameters, metric streams sync state enabled and import CloudWatch. And I will send this, it will update my integration to CloudWatch metric stream. And I will start getting data through the CloudWatch metric streams. Now we are going to focus on Kubernetes environments. In Kubernetes setup, we are going to use Helm. Helm is a very popular way to manage, deploy, and distribute Kubernetes-based applications. We will deploy Splunk Open Telemetry Collector using Helm. And it is going to install the Open Telemetry Collector as a daemon set and all the nodes of my Kubernetes cluster. Now I'm going to configure my logs ingestion to Splunk cloud environment using Splunk Connect for Kubernetes. And this is the configuration file that we will use, values.yaml. I'm going to mention Splunk I created a HTTP event collector. I have, this is my host, and this is the token for my HTTP event collector, and port 8088 is default. You can customize by reviewing the option here in the Helm chart. So let's go ahead and deploy my Splunk Connect for Kubernetes. It is going to use the values.yaml file that I showed you earlier. So it has now deployed the log collection on, as a daemon set, on all the 4 nodes. So once we set up getting data in, we can go back to Splunk Infrastructure Monitoring and see the Kubernetes Navigator in action. So for that, I'm going to click on Infrastructure and Kubernetes. So here we can see that I have 4-node Tech Talk cluster. And let's click on this node. So by visually, we can see that everything is working fine on this node. However, Kubernetes Navigator is telling us that this pod, there is something wrong just by visually inspecting the container. So this is the node. This smaller square is the pod, and the rectangle, smaller rectangle, represents a container. So just by clicking on this, we can see there is something wrong in this pod. We could now go back to Splunk and take a look at what is wrong in Splunk. So here, as I click on this, you saw that we are put into logs from the Kubernetes environments within context. That means that I did not have to write SPL. It carries the context of the object, in this case, that pod that we were investigating or we were monitoring within a Splunk Infrastructure Monitoring. So we were looking at this pod, and when we went to Splunk using data link, we can see what is wrong with this pod. So here, just by one click, we can see that, hey, there is a back off restarting field containers. So this usually happens when there is something wrong in the application code and the application crashes. Now go back to our slides. I also want to show you the out-of-the-box integrations. For example, here we are integrating with Nginx. Now, to configure this, we will just mention that the rule of a smart agent in Nginx. Rule is the port on which Nginx is sending these metrics, and the port name matches Nginx. And that's about it, right? So once we configure this, and we can take a look at our values.yaml file. This is what I have deployed Splunk OpenTelemetry collector with. So going back to slides, once we deploy this, we can go to infrastructure and look at the dashboards. So once you deploy OpenTelemetry collector, it will automatically collect Nginx performance metrics. So here we can see once we have deployed, it has started to collect performance characteristics for Nginx. And you can look at hundreds and hundreds of integrations that we have for OpenTelemetry collector, and how do you get information, performance metrics, monitoring for these integrations. I wanted to give you certain links that will help you accelerate your adoption of the product. So first is the training and certification. It is completely free training on Splunk Infrastructure Monitoring. Please feel free to click on this and sign up for this course. On the documentation for CloudWatch and CloudWatch metric streams, we were looking at the documentation earlier. This is a link to that documentation directly. For Kubernetes integrations, this is a link for Kubernetes Navigator and Kubernetes getting data in. OpenTelemetry collector, if you are deploying OTel collector on EC2 instances, which we did not cover in this webinar, but if you're deploying OTel collector on EC2 instances, there is the documentation. This is just a process that runs on Linux or Windows that you can take a look. For CloudWatch metric streams, we wrote a blog. So this is a link for CloudWatch metric stream blog. If you still have not started your journey with the Splunk Infrastructure Monitoring, I would highly encourage you to start your free trial at this URL. And if you have any question as you progress in your journey to Splunk products and Splunk infrastructure monitoring in particular, please go to community.splunk.com, search for this product, and we will have Splunk experts, community experts on the community website to help you progress in your Splunk journey. With that, I really want to thank you for your time and happy Splunking.